This video will be on section 12.3, logarithmic properties. So first I'll start by listing off the log properties or log rules that we're going to be using in this section. Then we'll practice them two ways. The first way, if you have a lot of logs to get separated, how do you bring them together as one? And then the other way is if you have one logarithm, how do you break it apart as a lot? And both of these are useful to know, especially for those of you that will take more math. And the last thing is some expressions involving both e and the natural log, because what's going to happen, especially when we do word problems, is the base of all our problems are going to be e. And when you solve and deal with them, the natural log is what comes into play. All right, so here are the three properties, and I like to annotate these quite a bit because it's easiest not to remember them as formulas, but to remember what they're saying. All right, now this part up here, b greater than 0, b does not equal 1, x is greater than 0, and y is greater than 0. All these are just necessary either from the definition or because x and y are inside the logs and they must be positive. But for now, we won't pay any attention to them. We'll just be okay with them. When we do section 13.1 and solve equations, when we use some of these rules, that's when we'll check what we're doing. All right, so the first one says log base b of x plus log base b of y equals log base b of x times y. All right, so the way to read this rule for me is addition outside. So we have addition on the outside logs equals multiplication inside. Okay, so we have log base b of x and log base b of y that are being added together, and when we combine them into one, we multiply the insides. Similarly, for rule 2, subtraction outside becomes division inside. Okay. Now, when we do subtraction and division, the order matters. So just notice here that the thing in front of the minus sign is on top. The thing behind the minus sign is on the bottom. All right, the last one is pretty important as well. It says log base b of x to the r power equals r times log base b of x. What's really happening here is they're moving the power out front to get it in front, but also you can move it from out front back to the power. So the way I think about this one is exponents can be moved out front, and then also numbers out front can be moved to exponents. So there are a couple things that we'll have to be careful on with these rules as we go through them. But for now, the only other thing I want to point out is you'll notice all the bases are the same. The bases must be the same to use any of these rules. The reason that that rule in the previous section is called the change of base formula, it's the only log rule where the base changes. The three things I have down here are just a side note. Many times people want to simplify other things and you cannot. So if you have a plus or a minus inside, cannot be changed. And then the third point here, if you are multiplying two logs, you cannot change that as well. Right, so that's something that these rules do not apply to. In fact, there's never going to be a log rule where you'll be able to change any of these. All right, so what we're going to do is really focus on bringing many logs together. So if we have more than one log and we want to bring them together, we look for pluses and minuses, and also this third rule will work in conjunction together. All right, so these are the rules that were outlined. The first thing is bring any coefficients up as exponents using property 3. You must do this first. So in order to bring them together, in order to use rules 1 and 2, you cannot have a number outside as you see the way the rules are written. What that means is in the problems here, if we have a number out front, we must move it to the exponent. And like I said, you must do this first. Now what's pretty nice, as soon as you move all the numbers out front to exponents, you just use rules 1 and 2. Whenever you see a plus, you get a multiplication. Whenever you see a minus, you get division. And if you have more than 2 logs to do at a time, it is highly recommended to work left to right and only do 2 at a time. If you have to do 3, it's going to be 2 steps instead of 1, but it's worth your time to make sure you're right. All right, but it's better to just work through these than outline the steps for too much. All right, so number 1 here, the directions here say simplify and enter the result as a single logarithm with coefficient of 1. So single logarithm, self-explanatory. We have 2 here. We want to make 1. So we want to bring them together. And then the coefficient of 1, what that means is we don't want any visual numbers out front. Right. And if there are any numbers in front, we got to move them anyway to bring them together. Now for the first one, you'll notice that there are no numbers. There's just ones in front of the logs. So there's no numbers to move to the exponents. And what that means is we can combine already. We can combine right away. Since we have addition here, addition outside becomes multiplication inside. All right, so log, our base stays the same. Notice it's 6 in both. It's still going to be 6. And we multiply the inside. So we got 11x to the 5th times 2x cubed. Now once you do that, simplify the inside. We got log base 6. 11 times 2 is 22. X to the 5th times x cubed. We add the exponents to get x to the 8th. And this has a coefficient of 1. There's no numbers out front, so this is our final answer. This is a single logarithm with a coefficient of 1. All right, number 2 is very similar, except subtraction, but you must check the first thing. First is that there are no numbers to move to exponents, and here we also don't have any numbers out front, no coefficients. All right, so that means exactly what we said last time. We can combine them. And here we have subtraction outside. Subtraction outside equals division inside. All right, so once again, we have the same base, which is going to be set up for us like that. The base stays the same. We have a division inside. The top's what's go in front, x to the 7th, and the bottom is what goes behind the minus sign, the 7x cubed. Now once again, if you can simplify, which we can do that, We don't have a number to cancel with the 7 on the bottom, which is okay, but we can get rid of the x cubed if we subtract 3 off the exponent on the bottom. Actually, let me not color through the whole thing. So what I'm going to do is take 3 from each exponent. And we get log base 4 of x to the 4th divided by just 7. Because when we take the 3 away from the x cubed, we have no x's left. And that is our simplified answer. We have a single log. The coefficient is 1. Right, so number 3 will finally be an example of combining them when we have coefficients. What do we do? All right, so you see number 3 here, we got 3 log of 8 plus 2 log of x, and we must move the coefficients. And rule 3 tells us to move the coefficients into the exponents inside. Right, and you want to make sure you move them appropriately. The 3 goes inside on the 8, the 2 goes inside on the x. Right, the log that it's stuck to is where it goes. So we do this first step, we get log of 8 cubed plus log of x squared. And now 8 cubed is a number, so let's just figure that out. 8 raised to the 3rd power is 512. Right, but once we're here, we got rid of the coefficients. This is what I was talking about before. If you get rid of the coefficients, then you can just combine them. And here we have addition becomes multiplication. We get log of 512 times x squared. And nice enough, we don't have to simplify. It's already simplified because there's nothing in common from the multiplication. All right, so that is how we make 2 logs into 1. For this class, I don't worry about more than 2, so you don't have to worry about that. If you take MAC 1140, we'll dive deeper into log rules. All right, so the other thing is expanding them. How to break logs apart. Imagine I started with this example here from number 2, my answer, and I wanted to get back to the beginning. How would I get there? Well, the way you expand is the exact opposite order of contracting. All right, so if you want to expand a single logarithm, what you do is you first break apart the fraction using log property number 2. Right, so I like to scroll up here to the log rules because usually when we read formulas, we always read them left to right, but you can use these right to left. So if you have a fraction inside, we can make subtraction outside, fraction inside, subtraction outside, multiplication inside, addition outside. And we can also use rule 3 in reverse. Before we were moving the exponent up, now we can move the exponent out. All right, but the first step is to break apart the fraction. After that, break apart any multiplications using the first property. And then the third and final thing to do is if you have any exponents, move them out front. And I'll go ahead and say it's important to do this one last. I'll explain as we do the problem. All right, so we've got 2 here. It says use the laws of logarithms to rewrite the following expressions in a form with no logarithm of a product, so no multiplications, no quotients, meaning no divisions, or no powers. And the first one says log base 3 of x to the 11th times the cube root of y to the 4th. Right, so before we go and do the problem, I just want to explain why do we not want to move the exponents out front first? It's because we don't have the same exponent on everything. The x is being raised to the 11th power, so we cannot just move that out front because the y is not being raised to the same power. And that's why we have to wait till last to do that. All right, so the first step is to get rid of any fractions, but there are no fractions to get rid of here. So we're good to go on that. The second step is to break apart any multiplications. And we do have a multiplication here. We have x to the 11th times the cube root of y to the 4th power. What I'm going to do is just rewrite this. Now, one thing I want to remind everyone is that we can do this now or later. It doesn't matter. But I'm going to do it now. I'm going to go ahead and rewrite the radical as an exponent. It doesn't matter if you do this now or in the next step. And just as a reminder of that, a radical is a fraction exponent. The numerator is the exponent inside. The denominator is the number on the radical. But now we can break it apart. We could have broken it apart before. I just like to get rid of the radicals. Multiplication inside becomes addition outside. So we get log base 3 of the first thing plus log base 3 of the second thing being multiplied. And now we have no more multiplications. There was only exponents. So we've taken care of the products and quotients, but now we need to get rid of the powers. So the third and final step, move the exponents out front. It's the only way you can move them. So what we mean by that is take the 11 and move that out front of its log. Take the 4/3 exponent and move that out front of this log. We get 11 times log base 3 of x plus 4/3 times log base 3 of y. And that is our final answer. Now, I think at the beginning this way is a little harder than bringing many into one. So if you kind of think about, if I take this, can I get back to the original? That might help you out a little bit. And the other thing, the only reason I wrote the multiplication symbol in here is so it doesn't look like 3 L's or 3 1s, to kind of distinguish what's going on there. All right, so the third one is one where we'll just have to do that first step as well. We have to take care of fractions. So the first thing we're going to do here is split up the fraction. We have ln of x to the 11th times y to the 20th over z to the 12th. And remember the subtraction rule, division becomes subtraction, division inside. Is we get the thing that's on the top inside minus the thing that's on the bottom inside. Okay. Now, once again, if you're more comfortable bringing them together, you can see if we brought these together, the way we'd get back over here. All right, so the second thing we want to do is break apart multiplications, and we do have a multiplication here in the first one. And we do that just like we did in the previous problem. We have a multiplication here. They become addition outside. So we get the natural log of x to the 11th plus the natural log of y to the 20th. So that is what this part became. And then in the second one, the natural log of z to the 12th is no multiplications. So that is it. And then the last and final thing to do, we notice we have no more multiplications anywhere. We have no more divisions inside. Now we can move the exponents out front. We take our 11, move that out front there. The 20, move that out front of the corresponding one, and 12 out front of the corresponding one. And we get 11 times the natural log of x plus 20 times the natural log of y minus 12 times the natural log of z. And that is our final expanded answer. Once you work a few of these, most people get the pattern down and kind of just can skip from the beginning to the end, which is okay. But it is a good idea just to take the time and a couple steps to do the work. You're less likely to make a mistake and look at it too quickly. All right, so the last thing is expression involving both e and the natural log. Now, since e to the x and the natural log of x are inverse functions, we have the two following properties. Ln of e to the x equals x, and e to the ln of x equals x. Right. And when we talked about inverse functions, we mentioned that when you do the composition of one with the other, you always get out x. So this is like replacing x with e to the x. This is like replacing x with ln of x. But these are just some rules to remember. It helps you simplify things. And it's good to practice them without using a calculator. All right, so the first one here, we want to evaluate the following expressions. Your answers must be exact in simplest form. So you can't use a calculator, but also no decimals at all. All right, so the first rule is the one when we have ln of e to something. It says ln of e to the x equals x. What it says is that the inside is e to a power, then the outside becomes, or the output is just the power. So that applies here to this one, but not directly. What we have to do is flip the fraction inside. We can't have e on the bottom. We need it on the top. And remember, when we flip the fraction, we change the sign of the exponent. So we get the natural log of e to the negative 5 and then over 1, but that doesn't do anything. Now we have it looking like our property here. The natural log of e to the negative 5 is just negative 5. Right. I might as well jump down to the third one since it uses the same property, and then I'll go back to the second one. So the third one, ln of the fourth root of e cubed. We know that radicals are the same thing as exponents with fractions, so change radical to an exponent. And we get ln of e, the exponent, the numerator is 3 and the denominator is 4. And ln of e to that power equals that power, 3/4. Once again, you have to type this in, so if you type in a decimal, even though it's a nice decimal, it wouldn't be correct. And then the last one uses the other property. This one's less commonly used, but it's still used. What this says is if the exponent of e is ln of x, then the output is x. This one's oftentimes easier to use because there's less you can do with log rules. So e to the ln of the square root of 5, well, that's exactly written like this. The output is that square root of 5, and that's all there is to it. Nothing extra to do there. You don't have to rearrange it because it's already in the correct form. But once again, if you type this into the calculator, square root of 5 is not a nice number, and it won't accept that decimal. Right. This is really the log properties that we need to learn for this class.